Hi everyone, my name is Rebecca and today I will be talking about Jevons Paradox. So today I'll be talking about what is Jevons Paradox, examples of the paradox, and what implications the paradox has. So it's generally understood that technological advancements that lead to increased efficiency is a solution to the depletion and emission of natural resources. Jevons Paradox debunks that belief. Created by the English economist William Stanley Jevons in 1865, Jevons Paradox is known as the correlation between increased efficiency and increased natural resource consumption. For example, people look at driving a hybrid car as much cheaper than driving a gas car because they are using less gas and therefore spending less money. This perception that people are saving money on gas and emitting less carbon into the atmosphere then leads to an increase in the amount that people drive, thus emitting the same amount of carbon as a gas vehicle, or in some cases more. From a coal consumption perspective, Jevons argues that improved coal efficiency leads to increased coal consumption because of profitability, new inventions and uses, and consumer behavior. For example, if the quantity of coal used in a blast furnace is diminished in comparison with the yield of industrial metals, the profits of the trade will increase, new capital will be attracted, but the demands for it increases, and eventually the greater number of furnaces will make up for the diminished coal consumption of each furnace. So essentially, if people feel that they're using efficient technology, they will consume more energy than they need and exponentially increase emissions, creating an energy paradox. Thus, technological efficiency will not result in the liberation from environmental damage as has been promised. It will in fact increase resource consumption, leading to ecosystem destruction, perpetuating irreversible environmental effects, and in turn have the exact opposite desired effect from a sustainability perspective. So what can we do? There are a couple ways to avoid rebound effects regarding Jevons Paradox. The first way is to implement public policy changes. Since energy rebound effects are driven by a drop in the cost of energy services, energy pricing can compensate for the reduction by increasing energy prices. Energy can also be taxed through resource rebound taxation. This policy can be implemented in the form of cap-and-trade systems or other forms of resource taxation. The second solution to Jevons Paradox is encouraging systemic change. Degrowth promotes change in the way humans relate to the environment, which will lead to the eradication of consumerism and material accumulation as a lifestyle, which contributes to the capitalist social structure that perpetuates climate change. A-growth is an alternative to degrowth because it states that economic growth should not be at the forefront of systemic change. A-growth is the idea that welfare and sustainable targets should be central in dealing with Jevons Paradox, and whether the targets produce economic growth is irrelevant. The new societal targets would be fixed globally and oriented to achieve a sustainable level of resource use. The issue with A-growth is having a globally agreed upon sustainable target, as well as the likelihood that it would decrease GDP, becoming an undesirable solution for capitalists and governments. So as we learned in an earlier presentation, simplicity is imperative in the world's path towards sustainability. We must all adopt a 1.5 degree lifestyle, no matter how energy efficient our new technologies are or become. Living within our means seems to be the most effective way to reduce our energy consumption and emission. Living overcomplicated lifestyles increases our energy usage and dependency, which exacerbates the carbon crisis. To know whether we are overconsuming, people must be educated on the topic. We need to know how much gas we emit weekly getting from one place to another, how much carbon we release into the atmosphere when our food is transported across the world, how much upfront carbon was used in the process of making our homes, buildings, and other material things, and so much more. Thank you for listening, everybody.